In this problem, consider a star of mass m2 kg revolving in circular orbit around another star of mass m1 kg with m1 is very much greater than m2. The heavier star slowly acquires mass from the lighter star at a constant rate gamma kg per second. In this transfer process, there is no other loss of mass. If the separation between the centers of the star is r, then its relative rate of change 1 by r dr by dt per second is given by. So this problem related to black hole dynamics. So what happens? Slowly the black hole will attract all the particles of any celestial body moving around it, and finally it will collapses into the black hole. Same thing they are talking about here. Let us take, this is what they have given. M2 star is there at some distance, m1 star is there, the distance between them is r. So the m2 is making rounds around m1. So when it is moving in its orbit, it might have orbital velocity it is having. So what happens? Because of this normal gravitational force acting on m1, m2, slowly all the particles will be separated and take the spiral like this. See, this is m1. So small particles, I will take dm2. So like this small particles, they will slowly they will lose their energy and the radial velocity increases, and finally they will collapse. That mass is attached to m1. This is what happening. That's what they told in the problem. So here orbital velocity is there, but the motion of m2 is not perfectly circular. So it is not perfectly circular. Then what happens? What we do, at some instantaneous position of this body m2, I will draw a straight line to m1. So in this direction, the central force is acting. Some radial force is acting. Centripetal force is acting. So this is the direction of that one. So I will draw a normal here. This is normal, right? So this normal is making small angle alpha. The part is this particle dm's, m2's radial velocity is this one. This velocity's components also we can have. This is also alpha, right? This is what it is. This is radial force. In this direction, the particle slowly comes and they will collapses. So this is, in this direction, they will have a radial velocity. So these are the things according to the problem given. So what are the things they have given? Number 1, m1 is very much greater than m2. So m1 is very heavy star and it is dragging all the particles slowly towards it, right? So number 2, what they have given, this rate of mass extracted towards m1 is dm by dt is given as gamma kg per second. And third, what we know from this small analysis, this radial velocity is equal to the component of this velocity. See, this velocity of a body of m2 in its orbit v. So the v velocity is, see, vr component vr is the component of v. So this is the direction of v. So sine theta, this is the direction of the component of v. So v sine alpha. So alpha is very much less. From that, what we can write, that means sine alpha is equal to alpha. So VR I can write like this, V alpha. From this, alpha is equal to VR by V. This is nothing but orbital velocity only. Got my point? That is changing. The rate of changing we have to calculate. Anyhow, let us come back. So these are the things they have mentioned in the problem. From the analysis of the given data, these things we have written aside. So here V naught, the orbital velocity V naught is equal to, that formula we know as G m1 by r. The mass of this m2, the velocity of this m2 is not affected by its own mass. It is affected by the second star's mass. This we have to differentiate dv naught by dt. Why? Because rate of change we have to calculate. So that's why this equation, for my simplicity, I will write like this. Root g is a constant. This is root m1, means m1 power half. R, root r is in the denominator. It comes to numerator, then r power minus half, like this. So in our differentiation, this is u, this is v. So you know the formula for differentiation of uv. So u into dv by dx. So root g is a constant, so I will write outside common. So u into, u is m1 half, dv by dt minus half r minus half minus 1. So differentiation over into dr by dt plus, now v into, v is r power minus half. I have to differentiate this one. How? 1 by 2. Sorry, it is plus 1 by 2. M power 1 by 2 minus 1 into dm by dt over. Differentiation is over. Then let us simplify this one. dv naught by dt is equal to root g. What is here? Minus. Here minus is there na? Minus 1 by 2. M power half means root m1. This m power half minus 1. So m power half minus 1 becomes how much? R power half minus 1 becomes how much? R power minus 3 by 2 into dr by dt plus, this is half plus half. So this is 1 by 2. 1 by 2. R power minus half means root r. It comes into denominator, and m half minus half. So it also comes into numerator. This is m1 into dm by dt. Right? Let us further simplify this one. How? dv naught by dt is equal to, I will take common, root 2 is also there, and m1 by, see I know na, v naught is equal to, what is the formula? Root of g m1 by r. This I will take common in both of them. How? Root g, here minus root m1 is there, this is 2. This r minus 3 by 2 I will write like this, root r into r dr by dt. Here root m1 is not there in the numerator, so I will write like this, plus 1 by 2 root r root m1. I will multiply with m1 root m1 and divide with root m1 into dm by dt is nothing but gamma. dm by dt is nothing but gamma. They have given already gamma. Then let us take the common. Which one? Root g m1 by r. So dv naught by dt is equal to root 1 by 2 also comes common. Root g m1 by r I will take common. So what is there inside? 1 by minus 1 by r dr by dt plus gamma by root m1 into root m1 m 2 m1. This is what inside. this 2 came out, so no need to write here. So this is the value of this one. I will further write like this. Root gm1 by r is v naught, so I will write so v naught square is equal to gm1 by r. So here gm1 by r, this one is v naught, so v naught by 2 into minus 1 by r dr by dt plus gamma by m1. This is equation 1. So what I did, rate of change of orbital velocity we have calculated. Now why this rate is change in this tangential velocity? See here in our picture, this tangential velocity v naught is changing. Why? The change in velocity can takes place because of force only. Here we are having force towards the center, radial force is there, centripetal force here. This force's tangential component is changing this velocity. So what we write here, tangential force changing v naught. So what is the tangential force here? See, let us look back the diagram. See, this is the force. This tangential direction force is F sin alpha. This is cos alpha, this is sin alpha. So here write this tangential component of force F. Tangential component of force F is equal to tangential component F sin alpha is equal to F is equal to ma, whose velocity it is changing, m2's mass. How it is changing? dv naught by dt. Alpha is very small, that's why I can write F alpha. F formula is g m1 m2 by r square. What is alpha? Alpha formula is here, see, at the right corner it is visible. Here Vr by V naught. So this is Vr by V naught is equal to m2 dV naught by dt. So here m2 cancels. Now see gm by r, v naught square is equal to gm1 by r. So I can write this thing, v naught, one more r will be there here, this is v naught square into vr by v naught is equal to dv naught by dt. What is dv naught by dt value? I will write here, v naught by 2 minus 1 by r dr by dt plus gamma by m1. Why? Since equation 1. Right? So what are the things cancel here? V naught cancels. So this 2 comes here. Then what happens? 2 by r, 2 by r, here 2 by r is there, Vr. Vr means dr by dt is equal to, Vr means radial velocity, radial distance by time. So dr by dt minus 1 by r into dr by dt plus gamma by m1. Right? So this term I will send this side. So this is 2 by gamma dr by dt plus 1 by r dr by dt is equal to gamma by m1. So here 2 by r plus 1 by r is equal to 3 by r. So 3 by r, this are 3 by r into dr by dt is equal to gamma by m1. So 1 by r dr by dt magnitude numerical value is, this 3 comes here, gamma by 3m1, but r is decreasing. R is decreasing with time. So 1 by r dr by dt value is, it is decreasing. That's why the value comes negative 3m1. This is the answer for our question. Let us see which option is correct. So for question number 4, no option is matching with this one. We got minus gamma by 3m1. So this is the correct answer, but no option is there. Maybe you are going to get bonus marks for this question. Some more small mistakes are there. This is in this no option is there. In other small mistakes are there in the paper 1 also, but answer is coming. We have some option, but here option is not at all there. So in that errors problem also some mistake is there, relative error. Anyhow, this is the answer for this question.